Okay, so far, first thing we learned was by factoring, then square roots, then completing the square. We learned the quadratic formula, and today we're going to talk about solving by graphing. And I forgot to erase all this stuff. Whoops. Okay, so my standard form for a quadratic equation that we would graph, or a function, is y equals ax squared plus bx plus c. A, b, and c have to be real numbers, and a cannot equal 0. In other words, there has to be an x squared in order for it to be a quadratic. So to check to see if a point is on the graph, you do the same thing we did when we had lines. You just plug it in. Really easy. So if we look at example 1, we're going to tell whether the point is on the graph of y equals negative 3x squared minus 4. So if I look at the first one, 2 is my x, 1 is my y. So I have y equals negative 3x squared minus 4. So where the y is, I put a 1. And where the x is, I put a 2. And 2 squared is 4. So then I have 1 equals negative 12 minus 4. Is that true? Does 1 equal negative 16? No. So that means that that one is not on that graph. Okay? Let's take a look at negative 1, negative 7. So again, this is my x, this is my y. So y equals, so negative 7 equals negative 3 times x squared, so I've got negative 1 squared minus 4. And when I square negative 1, what do I get? I get a positive 1, yeah. And so then I have negative 7 equals negative 3 minus 4. Does this one work? Yes, it does. So that means that that point is on the graph. Okay, so on your whiteboards, I want you to tell whether this point is on the graph of y equals x squared plus 2. So we'll start with the point 1, 3. So let's plug it in and see whether or not it works. Okay, so if you plug it in, you're going to plug in the 3 for the y, and then 1 squared plus 2, that's just 1 plus 2, right? Which equals 3. So what's the answer? Yes. Okay, that one works. All right, let's take a look at this point and see if that one's going to work. Okay, so I'm plugging in 3 for x, 9 for y. So 9 equals 3 squared plus 2. I end up with 9 equals 9 plus 2. That's impossible, right? So this one is not on the line. All right. So the graph of a quadratic function is called a parabola. Graph is a parabola. If A is positive, then that means that the parabola opens up. And if it's negative, it opens going down. So I'm going to show you some graphs and just give you an idea of what they look like. So for instance, I could have this one, and in that one, A is positive because it's going up, right? And if it's opening down like that, that means that A is negative, okay? Now there are certain characteristics that every graph has. One of them is called the axis of symmetry. That basically they're a mirror image on either side of the parabola. And so that's your axis of symmetry. You guys know what it means to be symmetrical, right? It means they're the same on each side. Okay, so that's your axis of symmetry. The vertex is the point either at the top or the bottom, depending on which way it's going. So that's the vertex for that one, and the vertex for the other one. In this case, the vertex is at 3, -1, and over here my vertex is at 2, 4. So when we have a parabola, we're going to have either a minimum value or a maximum value for the function. Okay, when I'm talking about the value of the function or the value of the graph, I'm talking about the y value. So in the case of my graph on the left, it's opening up, so this is that a high point or a low point? It's a low point, so it's a minimum. And so the minimum value in this case is -1, because that's the smallest that y is ever going to be, is a -1. And on my other graph, it's a high point, right? So that is actually a maximum. And my maximum value, what's the most y is ever going to be? 4. So my maximum is 4. So when you're looking at either your minimum or your maximum, it's just the y value of the vertex. And it's kind of the opposite of what you would expect. If the graph is going up, you always think of it like being bigger. But when the graph is going up, you have a minimum. So it's kind of like the opposite. If the graph is going down, you have a maximum. So you want to keep that straight. It always helps if you just draw it and say, okay, is that a high point or a low point? And then you'll know whether it's the minimum or the maximum. All right, so let's take a look at an example here, and we're going to tell whether the graph opens up or down. So in my first one, it's already in standard form. I just don't have a bx or a c, do I? But I can see that a is equal to what in this one? A equals a +4, right? So if it's positive, which way is the graph going? Up. Okay. Now if I look at b, I don't have it in standard form, so I need to get it into standard form. So what I'm going to do is I'm going to add this 7x² to both sides. Then I have -y equals 7x² plus 2. Am I done yet? No, because it's still a -y. I need to divide everything by -1. So I get y equals -7x² minus 2. So what is my a value for this one? -7. So which way is it going? Down. All right, so on your whiteboards, I'll let you guys do those too. Tell me if they're going up or down. Okay, so the first one was pretty obvious, right? What do you guys think? Up or down? Down, yeah. On the second one, though, you needed to subtract the 2x² from both sides. And so then you get y equals -2x² plus 5. So which way is this one going? It's also going down. Okay. So just be careful on those kind of questions. Make sure you put it in standard form before you just determine whether the parabola is going up or down. Alrighty. So now we're going to find the vertex, and then we're going to give the minimum or maximum value of the function. So if I look at A, you guys have it in front of you on your notes, right? Do I have a volunteer to tell me what the vertex is? Right, I'm looking for the point that's the top up here. So yeah, that's at -5, -3. And is that a maximum or a minimum? It's a max because it's a high point, right? And so then the maximum value of the function is just the y coordinate, or -3. Alrighty. How about, do I have a different volunteer to tell me the vertex on B? Saxony? Yes, -2, -4. And so is that a max or a min? That one's a minimum. And what's the minimum going to be, folks? -4. You just take the y value, okay? Okay. All right, domain and range. So we talked about this when we had linear functions before, but in case you've forgotten, the domain is your x values, the range is your y values. So domain and range of a quadratic function. The domain, unless you were told otherwise, the domain is always going to be all real numbers, unless there is some restraint. Like if it was a word problem and you're kicking a ball, the ball, you know, is not going to go a negative distance, so x would have to be greater than 0 in that case. But those are the exceptions. Most of the problems you guys are going to be doing, your domain is going to be all real numbers. So to figure out the range, we're going to have to look at the graph, and we start off by finding the vertex. And so in this, well, so first of all, on the first one here, my domain is just going to be all real numbers, right? But my range, I take a look at it, and it's going up, isn't it? So we're talking about the y values. So they're getting greater or smaller? Are they getting bigger or smaller? They're getting larger, right? So it's going to be greater than or equal to whatever the lowest point is. What is the y in this one? 1, right? So it's going to be y is greater than or equal to 1 for the range. Because 1 is the lowest number y is ever going to be, and then it's just going up from there to infinity. That's what the arrow's on the end means, it's infinite. All right, let's take a look at this one. So what do you guys think my domain is? What is it, everybody? All real numbers. And this time, it's going down. So do you think it's going to be y is greater than or y is less than? Right, it's going to be y is less than or equal to, because the vertex is included in it. So we also have to include the vertex. So if I look over here and see what this point is, it's -5, -3. So what's the most y is ever going to be? -3. Okay? Any questions there? Alrighty, let's see here how we're doing. Okay, so in the interest of time, I want to do a couple of the graphs before we run out of time. Okay, so let's first look at, oh, not that one, next page. All right, so now we're going to talk about graphing parabolas with a table. And I can't remember whether tonight's assignment has any graphs on it, but these initial graphs that I'm going to be giving you, you should be able to make a table and have it come out okay. Basically, you know a parabola is always going to look like either a U going up or a U going down, right? And so you need to keep plugging in points until that's what your graph looks like. Now, most of the time, it's going to work to just center them on 0 for the problems you're going to be having in the next few days. But every now and then, it'll be off a little bit. And so you might have to add a few more numbers to your table. But let's start off with -2, -1, 0, 1, and 2, and see what we get. So first of all, take a look at my equation. I've got y equals -2x squared. So what direction are you expecting this to go? Up or down? Which way? Should be going down. So when you go to graph it, after you fill in your numbers, if your graph isn't going down, then something went wrong and you need to go back and check your work. All right, so let's take a look here. So if I put a -2 in, what's -2 times -2? +4, but then I multiply it by the -2 out in front and it becomes -8. On the next one, I'm going to put in a -1 and square it. So -1 times -1 is +1 times -2. I get -2 for y. What about if I square 0? It's just going to be 0. Yeah. Now if I put in a +1, I'm going to get -2 again. And when I put in a +2, I get -8 again. Because 2 squared is 4 times -2, I'm back to -8. So you see how it's making a pattern that's symmetrical? It's the same on either side of 0. And so you want to look for that symmetry when you're graphing it. All right, then it's just a matter of plotting the points. So -2, -8, -1, -2, 0, 0, 1, -2, and 2, -8. And then you just draw the curve going through it. Okay. Any questions on that? All right, let's skip down to that last graph that has a fraction on it. Because in this case, if I choose -2, -1, 0, 1, and 2, am I going to end up with fractions? Are fractions easy to graph? No, they're a pain in the neck. So what number would I have to multiply by to make the fraction go away? 3's, right? So I'm going to use multiples of 3. So instead of -2, -1, 0, 1, and 2, I'm going to use -6, -3, 0, 3, and 6. And that way when I put it in, my fraction is going to go away. So -6 times -6 becomes 36, and 1/3 of that I get 12. And then when I plug in the -3, I get 1/3 of 9, which is 3. If I plug in the 0, I'm going to get a 0 again. And then when I plug in the +3, I still have 1/3 of 9 again. So that's 3. What do you think my last one's going to be? Yeah, it's going to be 12 again. So now when I graph it, I go to -6, 12 is going to be about here, -3, +3. Which way are we expecting this one to go, by the way, up or down? Should be going up. All right, 0, 0, 3, 3, and then 6, 12. And it is going up. Now, how does this one look compared to the other ones we've graphed? It's a little bit wider, isn't it? That's what happens when you have a fraction. It gets wider. But if you have a whole number, like we did up on top, it actually gets skinnier. The bigger the number A is, the skinnier it'll get. So see how that one's real skinny? And that one's fat. So that's what the A will change the width, basically, of your parabola. All right, and that's all I have for you guys today.